Alright, so welcome back for part two. Now we're going to try to figure out the effect of changing the concentration of B will have on my rate. So here I'm going to go to find two trials where B is different. However, the concentrations of A hasn't changed and the concentration of C has not changed. So let's see, I'm not going to use 1 and 2 because B doesn't change. I can use 1 and 3. And let's see, in 1 and 3, A has the same concentration. Good, and B or C also has the same concentration. So I'm going to use runs 3 and 1. And I'm just going to do the same thing as I did before. So this is going to give me, let's see, 3.02 times 10 to the negative third over 1.25 times 10 to the negative third as well. That'll give me 3. And then I'll do my rates. Actually, not 3. Let me hit the old calculator here. That'll actually give me 2.4. Whoops. 2.4. We'll call it 2.42. Now I'm going to do the same thing for my rates from run 3 and run 1. In run 3, my rate was 0.0508, and run 1, 0.0174. Again, do the division. This one's not going to be as nice as the run 1, or I'm sorry, what we did for concentration of A. Hold on one sec. I just realized here I wrote in the rate for trial 2 by accident, so 0.0087. So if I do the math here, 0.0508, divide that by 0.0087, that'll give me 5.84. So, these aren't really nice, pretty numbers to try to figure out. Well, 2.42 raised to what power will give you 5.84. So this is where we got to do, to find n, we're going to do the log of 5.84 over the log of 2.42. And if we do this, we'll end up with n being very close to 2. So we can just not assume, but we can round it to 2. Alright, so that's our rate law with respect to B, meaning if we double the concentration of B, we should see a 4-fold increase in my rate. It's a second order. So now let's see what happens when we find out how to do this last part here. What are we going to get when we look at how changing the concentration of C changes things? So here we want to find two runs where only C changes. So let's see, if we do 3 and 4, well, it definitely changes for C. It stays the same for B, it stays the same for A. Perfect. So let's do run 4 over run 3. Let me use my concentration. So 3.75 times 10 to the negative third over 1.25 times 10 to the negative third. That'll give me 3. And then now I'm going to do the same thing for my rate. 0.457, just getting that from up here, over 0.0508, and this will give me 9. So 3 raised to what power will give me 9? Well, it turns out that 3 squared will give you 9. Alright, so we're one step closer to figuring out my whole rate law. I now know what M, N, and P are. So if I just go back to this, fill in the numbers that I just got. I had a 1, a 2, and a 2, which means my overall reaction order is just the sum of my exponents. In this case, my overall reaction order, or order of the reaction, is 5. And for each of the reactants, for A, it's 1, for B, it's 2, and for C, it's also 2. Alright, so now we're going to do the next video. We're going to spend that trying to figure out the value for K. So let's see how we go ahead and do that. So when you come back, in the next video, all this will be gone. I need some more room to kind of show how to do that.